Hello, welcome to another stream today. Just setting up the little chats that we have here. Welcome. And there you go, guys, we are ready to go now. How is it going today? How is everyone doing on this fine Saturday evening? If you're watching this later, I hope you're having a good day as well. And yes, let's go for it. Let me just change the audio a little bit, because I know it'll probably be too loud. And then on Spotify as well, I think it's the right volume now. But please do let me know if it's a little bit too loud for you guys. So in the stream, I thought we would actually continue the audio visualizer work that we were doing by trying to take a step further from our last stream and actually play the audio data that we managed to load in with the Wave file reader library that we added into the project, right? So what I did just before the stream here was to actually read the audio notes that we wrote a couple of streams ago, where I basically planned how I'm gonna develop this whole sort of like audio player with Qt. So some of the stuff that definitely brought to my attention here, was the Q audio probe, and this is a class that in Qt that basically you can connect to the audio output device, as well as other classes that want to look at the data that are the audio data that's being played currently. Because this is going to allow us to basically get the same audio data that's been played currently on the speakers, right? So this is the Q audio probe, and that's kind of what it does. It's just like a class that allows you to sort of like connect to the audio output. And then obviously Q audio output, I still think we're going to need that to actually output the audio. And yeah, I mean, this is pretty much the plan for now. In the last stream though, I was basically just adding everything to this basic class here, or to the basic main function. What we did have was like an audio file passed into the program, and with that audio that we passed into the program, we just read the information from the I think it's called audio file library. So let's actually do some refactoring here and move this stuff into the audio playback library that I'm going to create here. So obviously before that, I do actually want to get this to sort of like compile. I'm going to turn it down a little bit just for me here. And let me know if you can still hear the music. If not, that's fine. Yeah, I want to get this to compile, so I do want to look at the CMake list that I had, and I see I have none of the libraries that I actually need here. So find package. I will need the Qt6 multimedia class, because this contains all the Q audio format, Q audio output, and Q audio buffer classes that I need. Is there anything else that we need for now? Yeah, there is. So we need to find package on the audio file. I think it is. I'm not sure if it was audio file altogether or if it was just audio underscore file. And we can look at what we linked into the main file anyway. Yeah, so it's audio file altogether. That's kind of what we need here. So this is what we're going to put in our target include or target link libraries, right? Oh. And obviously I just need Qt6 and then require that. I can see that there's a little bit of, there you go. Just removing the little line on the comments, and we still have a little bit of that. There you go, it's gone now. Making the stream a little bit prettier for you guys. Oh yeah, so we're adding this library here called audio playback, and this is where I'm going to put all the Qt audio abstractions. We have a target include directories. Okay, for the include headers, that's fine. We don't want an executable, but what we do want is a target link libraries, right? Because we want to link all these Qt libraries that we need here to our audio playback. So audio playback, and then we want a private linkage for now. And the ones that I know that we need for sure are the Qt6 multimedia, as I said. And before that, we do actually after that, if you're doing alphabetical ASCII order, we have audio file, audio file. So let's kind of just take a step back a little bit and try and design this whole API. Let me put this on the side here. And by that, I mean, let's open ScaliDraw and try and design what this should look like with boxes, right? So we do have something called the audio file itself, right? So we have the audio file object somehow in here. This is not, why is this not? There you go, audio file. Text-wise, can I put it at the top? Yeah, I can put it at the top. So I would like to have some sort of class that represents an audio file, right? And then in here we can have something like a load class, a load, what do you call it? A load method. Or we can just be part of the constructor, right? So audio file, and we have the actual path to the file or something, right? Or we can have an audio file with the binary data as well, right? So the bits here, so the bytes or something, I don't know. So these are the constructors for us. What we do need as well is a way to kind of get the data. So how do we do this? I mean, in the audio file library, I know there are functions to get the channel data, right? So the info. So let's have a print info here. Or let's have a get format function, and this is going to get the Qt format, by the way. So the Q audio format. Bobby, cool. Hey Bobby, how's it going? Welcome to the stream, dude. We're doing some Qt programming today. Yeah, so let's have this for. You are smart. Not quite, man. Not quite. I just trial and error everything. But yeah, tune into the stream, give it a like, and hopefully you understand what I'm doing as well. I'm just getting some audio playing on the program here with Qt. But as I was saying, the audio file class does need a get format function, which will return the Q audio format, which is what we're going to need essentially to set the audio properties for playback, right? So let's have that in there as well. We can also have a get channel data, shall we say, or something. Maybe we can have an integer here, and that will return the a Q buffer, Q audio buffer or something, right? And these are like structs that we get provided by Google, by Qt, essentially. What else can we have at the moment? Yeah, in terms of like playback, I think this is what we're gonna need. So let's try and create this, and then see if we can just wrap around the audio file library. And obviously, for pretty printing stuff, not needed. But just for debugging, we can have something like a pretty print or something, and it's just going to print the audio information, like how many channels he has, how many samples he has, like samples per second, the precision, like is it double precision samples, as in like is it a double sample, is it a floating sample, and so on and so forth. So let's do that. Yeah, I mean, what I do want to do is obviously to add a new file here on my audio playback library, and let's call this the audio file, right? Audio file.h. And then we're gonna just do an if and there for a guard here, because we're not using modules yet. Audio playback, and we've got audio file h. Just gonna copy this, and then we're gonna define here, and then we're also gonna add the endif there. Okay, so that's our include guard, and then obviously we needed the audio audio file class, right? That's what we wanted in the first place. Cool. And just to get that compiling, we're going to look at it in a second. We do need a Qbegin. Is a Qt begin namespace? Because we want to forward declare some of the classes, you see. Or in fact, not even Qt, because we're not wrapping that around. But we do need to include here the Q audio format, because that is one of the types we're going to be returning, as you can see, and the Q audio buffer as well. So those are like the Qt includes that we're going to need for this anyway. Cool. Now I'm going to create a new file, a CPP file, just to include this header, so that, you know, I can find these headers here. So audio file, I think it is, that's CPP, yeah. Sorry, so in my includes I have the headers, and in the CPPs I will actually have the definition, right? So in here I can do an include audio file.h, right? That's what we want in the end. Obviously this is CPP file that I've just added, is not part of my library yet, and I can do that by just kind of putting it here now. Audio file.cpp. Okay, so that was the CMake changes that we've made. Let's just do a reconfigure here to make sure that the changes do go through and we get the IntelliSense working for us, because I feel like it's kind of a hit and miss with VS Code. Okay, so Q audio device actually does seem to compile fine, you see. This is interesting, because this is just some pseudocode I wrote in the last stream to make things work in my head. The Q audio file and Q audio format, so kind of open source. Now, why can't this be open? I don't know yet. It's probably because the audio file doesn't. Oh, it does include that. There you go. It doesn't find it. Include errors detected based on information provided by configuration process. So have I made a mistake here? Audio file, add library, audio playback, and then audio playback itself has linkage on Qt multimedia. I just realized as well that this does have to be a public linkage here, because the targets, including my audio playback, will need access to Qt headers, right? So let's do it that way and then remove that from here. And we still haven't found it. Reconfigure. Maybe if we do a build as well, just to make sure IntelliSense kicks in. I can see if it still hasn't found the. There you go. We did find it out. No, we didn't. Why did you not find it? Include audio playback. Is it because I don't have audio playback here? Could that be the reason? Audio playback, audio playback. Let's build it. Still doesn't find the header. Great. There's audio file.cpp, audio device.cpp added. No, it still also doesn't find it. I mean, that's okay. It's actually probably because I haven't included it here. Looking about it. Add subdirectory, source, audio, playback. Cool, yeah, so it kind of makes sense why I didn't do that. Yay, now we've got everything working. Yeah, just a stupid mistake by me. Sometimes happens when you forget to add your like library CMake to the main CMake path. Yeah, that's okay. But yeah, going back to audiofile.h, let's just drop down this class's definitions here. So we want some private functions, we want some public, What we do want as well here is we want to say that we have a class called audio file. Ooh. But we cannot do that. See, like this audio file header, which is the library I'm actually using to read the WAV files, has a class called audio file already in there, right? So I'm pretty sure that my name here would interact. Let's just call it WAV file for now, so I don't have to worry about it. And also, I wanted to basically not include this header here, not cascade it down, and actually just forward declare the audio file template type name T here. Yeah, I just wanted to declare that we do have a templated class called audio file, because then I can just have it as a unique pointer in here. So unique pointer of audio file of T, and again we need the template here. We're going to template this class, and the reason for that is that the this audio file class, which comes from the audio file library that I'm using to read WAV files, is templated on the type of samples. So for example, you can have double samples, you can have floating samples, just float samples. You can also have integer samples, so it needs the type left there. But that's fine, you know, that's okay. What we can do now is, obviously we're going to include memory here for the unique pointer, and we're also going to do, you know, the usual, our custom unique pointers, I guess. So using audio file pointer, and that will be equals to a unique pointer of type audio file of T. But we also have a audio file deleter here, right? Of T as well, I guess. That'll have to be a type. Now audio file pointer. Does this work? Yeah, it seems to work so far. Yeah, the reason being is that we will need a custom deleter. Or do we? No, yeah, we don't, because this class does not need a custom deleter. I think it just has, if you look at the actual audio file here, it just has a destructor, right? So it should be fine with it. Yeah. Good. It just has a default destructor, so it should destruct. Which, you know, saves us a lot of work, actually. We don't have to create a custom unique pointer for this, so we can just do this here. And let's just call it the audio file itself there. Now onto the functions that we actually said we're going to create, and I'm not sure if you guys can see that very well here. Maybe if I zoom in a little bit. There you go. So we definitely wanted a few constructors, but let's start with the, I guess, the behavior of this class, the methods. So we want a function that will create, that will get us the format, and that is going to return us a, I think it's Q audio format, right? That's what we want there. Obviously we want a const. What else do we need? We need to get channel data, right? So get channel data, that's going to return us a Q audio buffer, get channel data, and then we want an int for the channel here, or simply stud size T. That will do as well. Actually, it might be overkill. So int size T channel. Okay, so these are, you know, the main two functions that I want from my class here. And for now, let's just add one of the constructors, which is the WAV file that takes in a stud string as the path. And this function is just gonna, you know, create a wave file from a file in the file system. And then path is a valid path to a wave file, right? That's all we need to do. And here as well. So this returns or gets the chorus, the Qt audio format corresponding to the format of the loaded file. Okay, returning a format, the Qt audio format. Okay. So what are we doing on this one? So yeah, this just gets the channel data, right? So we, oh, there you go. So this function will return the audio format inside the requested channel in the audio file. Quite easy. We just want to, you know, if you think of about a stereo wave file where it has two channels, the left and right. If we pass in, you know, channel 0, we want to get the left one. I think 0 is usually the left one. So we're going to return just like basically a big vector of that data, which is the Qt audio buffer here. So channel has to be a valid index to an existing channel. Okay, and then return the Qt audio buffer containing the data in the channel. Okay, cool. So this is what we're gonna develop against, right? So now let's just copy this class definition here. And I've got an idea as well, guys. So let's just drop this template, yeah, because I'm gonna do just a flow here. Because I don't really care about making this class work for different types. I just want to convert all of them into one type, which is float. And that makes it so we can actually define this whole class inside our little source file, right? That's what I want to do. Don't want to put all the definition there. Plus it's like, you ain't gonna need it, right? That's why you should be following all the time. Yeah, cool. So what do we need to do? The first thing we're going to define here is the wave file. That's the string. We've got a path there. And of course, we're going to include the audio file here because we're going to need to instantiate the pointer, right, to the audio file that we have. And we can do that by doing the audio file is equals to a new audio file of float, right? And I think that's kind of the code we need. And let's make sure that I've got the same code as here. So audio file, yeah, just that. Cool. And then inside here, I guess we can load it, right? So we need to load the data. So we can do something like if, I guess, audio file. This isn't Rust. Again, I'm losing the C++ ways. And we can pass that path in there, right? And that's what we're going to do here. So we have a pointer to the audio file here, right? Like ideally in the future, you know, that's just what to do here. In the future, we really want to drop this audio file because it, you know, it duplicates the audio data. We don't want to keep like multiple copies of that audio data in memory because it could be quite costly, right? If you've got an audio file that's like, I don't know, 10 minutes long or something, and you're copying that over 3 or 4 times in your program, it's going to become costly. So, but for now, I just want to get things work, so let's leave that there. Cool. And then the first function that we're going to do here is the one that returns the audio format, right? Is it a const? Yeah, it is a const. That's why it's complaining there. And yeah, this is where I come in and say I want the Qt audio format. Let's just and then this is where I'm again going to copy and paste some code that we did in the last stream just to get the format, and it was this code here. It's going to be the exact same thing, Copy these basically. I'm going to put a pointer here so I don't forget to copy these into my new stuff. Yeah, so this function is just generating that Qt object that we need, you know, the Qt audio format. And instead of audio file, I'm gonna just put a underscore, yeah. Right, so what is going on here? So yeah, so these are pointers. They are unique pointers. Cool. And yeah, we're good now, hopefully we're good. And the samples format is a float, right? So let me just make sure that it is 32. Is it 32? I don't know whether this is it should be a 32-bit floating point, right? Let's hope so anyway. Okay, so channel config, we've got config stereo. This is, I guess, one of the to-dos. So what happens if the file doesn't have only 2 channels, right? What happens? It will probably be one of these other channels here. So like you've got multiple audio formats supported in Qt for you in the Qt format. So I will need to figure out which kind of one it is. But yeah, I mean, most of the time it should be stereo, right? So we should only really support stereo. Maybe we can do a check in the program to actually do that. And yeah, we return the audio format. It's a very simple function. That's what we do. Let's go to the next one. Next one is auto wave file. What is it? Get channel data int I. And we're going to return an audio buffer. So let's just include the audio buffer here as well. Audio buffer. Let's go back here. And is this not const? The main thing, yeah, it is const now. Okay, so we can get rid of this now. Just to remind which functions we need to declare. Right, so this is quite interesting. So we want to return the whole data, right? So let's see how we can create a Q audio buffer given a vector of floats, because this is what it is. So it's a Q audio buffer. And I guess there will be some, I hope there is some configurations here. It's a predefined, yeah, I want to create a floating point 32 stereo sample, right? So I knew this before, but there is this sort of preset that I can use here. So let's try and do that. So if we do auto buffer equals Q audio buffer does this work? Is this a type? What is it? A type name is not allowed, yeah. So we have to just do this. Right, does it work? Yeah, it does work. So what is this? Just to make sure, it's a Q audio format floating. Okay. Q audio frame stereo. They both inherit from these. Anyway, I don't really care too much. I mean, Qt says it does what it does, so let's just trust Qt, right? It's interesting to know what it does, but so can we set the value? Can we set value? Channels, clear. Like, how do I set value? Position and value. So wait, what? So I can only create interesting. Let's see. So Q audio buffer play. Let's see how we play a Q audio buffer. Yeah, I'm also wondering whether I have to interlace the data, because if you guys have done some audio before, you usually know that when you're dealing with things like post audio, you pass post audio like a buffer of data, like a buffer of audio, but every other byte, every other sample, so usually samples are just a list of like floats or integers or however you want to represent them. But like every other sample would be for one channel. So like the left channel will be like index zeros in the index sample 0, and then the next one will be at 2, and then the next one will be at 4, 6, and so on and so forth. And then the right channels will be like the odd position, so it'll be like 1, and then 3, and then 5, and so on and so forth as well. So it's like, I think it's called interlacing. I wonder if this audio buffer expects an interlaced buffer as well, because currently the class only returns left and right channels, right? So we need to basically set that. Sample count. This means a buffer with stereo buffer. Yeah, interleaved. That's the word. That's what I mean. That's what I mean here. Returns the number of samples in this buffer. If the format of this buffer has multiple channels, then this count includes all channels. This means that a stereo buffer with 1,000 samples in total will have 500 left channels and 500 right channels interleaved. So from the documentation, there isn't much here. You see, I mean, this is one of the things, I guess, that is kind of lacking on Qt right now on this particular page here, is that if you create a 32-bit floating stereo buffer, you should be interlacing them, right? So in essence, we can't just return a channel data. In essence, we should just return the entire buffer, the entirety of it, right? So let's change our definition here of the function slightly. We don't have the channel here inside the requested audio file. We don't need this anymore, which means in here we don't really need the channel anymore either. And then we have to interleave the stuff ourselves. So this is actually very easy to do. The first thing we should be checking is if we have an audio file in the first place, right? Because if we don't have that, then we're gonna have a problem. And in fact, I don't remember. Yeah, we do have that. So if it's not there, let's also make this a little bit more modern and return a optional. And hope that this QAudioBuffer has a copy constructor, otherwise it's not going to work with the optional stuff. Include optional there. And again, let's change it here. Oh, what did I do? Right, so this should be good now, right? Yeah, there you go. I mean, if we don't have an audio file set, we should obviously return a no pointer. Oh, sorry, no lopped. No lopped. There you go. And this is just, if you do Rust, this is like an optional, and this is like a non-value, basically, or just a. If you don't do Rust, this is like a no pointer kind of thing. Quite nicer in C++. Whereas if we do have one, we can attempt to create a buffer, then we can set all the values, right? So like, how do we set data to the buffer? Because I can't really see any functions that will be, setting the data there. QAudioBuffer. Const by array data. Okay, so it does have a constructor here that takes those things in there. So this one creates a new empty invalid buffer, right? So actually what we've done here is created a new invalid buffer. That's fine. So what are the ones we actually want? We want a number of frames, an audio format, yeah, so this is what we want, right? We want this one. We want the number of frames, I guess. What is it? Create a new audio buffer with space for number of frames in the given format. The individual samples will be initialized to the default for the format. Start time in millisecond indicates when this buffer starts in the stream. This buffer is, if this buffer is not part of the stream, set it to -1. Okay, no, it's not part of the stream. Is a frame and the sample the same thing? Let's have a look. So what usually is, audio frame versus sample. A sample is a single numerical value for a single audio channel. A frame is a collection of time coincident samples. For instance, a linear PCM stereo sound file has two samples per frame. One for the left and one for the right. Okay, so this is how many actual sort of like left and right combination of samples we want. So that's fine, we can do that. And again, this is something that we can get from the audio file, right? So we can do audio file, get number of channels, get number of samples per channel. Yeah, this should do. So this is our auto const frame. Oh, num frames, right? That's what we want here. Okay, so we want number of frames and then the audio format. The audio format, as we can probably get from up here, right? So there's just a get format. And again, this should have been a check here to say if the audio file doesn't exist, the audio file doesn't exist, or is not valid because there's no pointer, we are going to return a null opt here. And let's put this inside an optional. And of course, we have to change it up here. I made a typo in here as well. No locked otherwise, and then obviously this should be STD, so optional. Sometimes my Vim bindings mess me up. Okay, cool. So this should work now, right? STD optional. Yeah, cool. So if we do as well, if we do an auto const format equals get format. And if this doesn't exist, if format isn't valid, we can just return a null opt as well. There is no login. I mean, ideally we'll probably do a login here, you know, log that the format wasn't created or something, but you know, we're just getting things done quickly here. Yeah, so now we should be able to do the fairly safe operation of dereferencing basically the pointer. Just format the value, I guess. And this will throw no suitable conversion from const to float exists. How? Qt audio format. Why is it taking the float? Because I essentially want this one. What is going on here? What is going on here? What if I build this? What happens? Because it should be taking this constructor right here. So integer. It is an integer. Let's see what it says here. Syntax error. Qt audio device should be preceded by. Ooh, okay, so we do have a little. Made a typo. And also, I do wonder what the actual macro is, right? Because I've got the same usage for the Qt begin namespace thing in here somewhere. Just give me a second. Is it here? No, yeah, it'll be here somewhere, right? Yeah, Qt begin namespace and let's go back to audio playback. So this declaration has no storage class or specifier. We don't need that either, do we? Now, how do I include these macros without including and leaking Qt stuff in? That's the point. Qt begin namespace. I wonder which header this is in, to be honest. It's basic Qt namespace. Qglobal.h, right? So we can do that. Let's try this one. Wait, I don't really care about this code at all. This is like code from the other stream. So why do I even give a shit about this? Let's just remove all of this for now. Not this though. Okay, so Q audio device info. We don't care about that for now again. Let's just build it out here. The following error is treated as the following warning is treated as an error. Conversion from const int to float requires a narrowing. Const int to float requires a narrowing. Now, why is this a float? I do wonder. Predefined specialization for a 32-bit stereo sample. So why can't I use it without having major issues? So QF 32F. How are these guys using it? Type def equals that. Oh, this is the actual code of Qt. I don't want that. I guess we can just create the audio buffer. It's not that difficult, is it? Let me just make sure that we've got, yeah, float, sample flow, okay. Let's build it here. I thought that by Qt providing the QF32S type, things would work a little bit better, but clearly not. If it's not a control paths return a value. Ah. You are quite right, Qt. Now it does. And what's the issue though? Error cannot open include file audio file.h. Where is that? Audio visualizer. Okay, yeah, that's because we don't really have the audio file code anymore here, so we can remove it for now. Q surface, triangle window, audio file. Yeah, this is the stuff we don't really want in here anymore, at least for now. Right. And things should build now, hopefully. How many times does it take you to change your code for you to build something in C++? 4 times apparently, so yeah. Okay, yeah, I mean, we have the buffer here, we have a number of frames, which is fine. However, we don't actually have the data. I mean, we should create, we should do interleave. We should get the interleaved data here, right? Now, I wonder if there's already a function in the audio file C++ library that does this, because I don't know. because currently I kind of only know that there is a way to get the data for one channel, but not for all of them. But that's fine. I mean, we can just do a quick and dirty for loop here. So for int I equals 0, I is less than audio file, get number of samples per channel. Opa. I mean, yeah, we already have that variable and it's called number of frames, right? So num frames, yeah. And then buffer the I times, well, let's think about this. So every odd index will be the left one, and every right index will be the odd one. So how do we do that? So I times 2 will be equals to the left one. So we do audio file what did I do? What the fuck did I do here? Yeah, so that's kind of what I want. And then this one is that one plus 1, right? So that's what we want. And why does buffer not take this? No operator matches the operand. What is it instead? Buffer dot data valid swap duration. Okay, so how do we set data? How do we set a data to an audio buffer? Let's have a look. This is what we're using. Creates a new audio buffer with space for num frames of a given format. Individual samples will be initialized to the default value format. Okay, so how do we set? How do I set something? Operator equals. So yeah, I guess we can use the data directly, right? Which is a little bit meh. I wish there was a function to just set something at an index. But we're gonna go with this. Buffer.data. And this is a pointer, so we should be able to, yeah, let's do this, right? Oh no. A pointer to a bound function may only be used to call the function, because it is a function. So returns a pointer to this buffer's data. You can modify the data through the return pointer. Must be a pointer, a function queue. What type is this? So if we do auto buffer dot data, function declared is inaccessible. Interesting. But it says it's a public function. So this is interesting. We've got a queue audio buffer. Pointer bound to function may only be used. I'm confused. I'm utterly confused here. So buffer data. Why can't I use the data? Detach. Let's just do a quick Google search. Qt6 set audio buffer data. Const data is a const there. That's I'm trying to use this one, but it says it's inaccessible. Oh, what does detach do? Detaches this audio buffer from other copies that may share data with it. Interesting. Now we don't care about that because it's only been used in this function here. So this is where I stare at the code and wonder why it doesn't work. Ah, is it because I don't have a type associated to it? Yeah, I mean it's because I didn't put the freaking type name there. What's qint? Keep the unsigned short. Guaranteed to be an unsigned. I want to float. How do I do a float here? Is it just the QReal? Let's configure with the -QReal float option. Huh, interesting. So I do need to have a type here. Also, it's getting a bit dark, so I'm going to turn this on. I'm breaking my keyboard apart as well as I speak. There you go. So we want Q audio buffer float data. That audio format is int16. We don't want that. We want a QReal, I guess, right? So QReal. Will it do the conversion for me? I guess it will. Yeah, okay, I guess it will. So I guess we can do a data there and also data here. Please tell me this works. Yay. Right, this was very difficult, but I hope this works, right? I hope this works. Two doubles. Yeah, and then we return the buffer there and we're fine. Cool, so essentially we have an audio format, right? Sorry, an audio file. So to test this, I can just launch the program and then just debug and see what comes out of that to see if like we get a gibberish data or something that's actually valid. And for that, I'm going to go into my audio visualizer because it's the only executable that I'm creating here. And I'm also going to add the audio, for testing, just the audio playback here. And then in my main file, I can do include audio playback, and then I can include that file, audio file here. And wherever I had this code, I guess I can put it here for now. I can do something like so auto const audio file wave file, and then I can do program audio file dot value, right? What's going on here? Oh, program args dot file, audio file, I guess. I thought this was an optional, hence the value there. Okay, and then I can do also the audio file auto right. So ideally, you know, they should build. Question is it gonna work? You know, is it gonna actually work? So I'm expecting to see some audio buffer with some actual data, but it doesn't compile. And why? Use of undefined type. Sorry, which type? Use of undefined type audio file of float. Is it because it doesn't like my class definition here? Let's see what the issue is. So that's what I'm trying to do. You can't declare a template class's definition states default, but anytime you reference a class, you must include all its arguments until the definition is introduced. What do you mean? So we've got a template to struct foo and a template class t. Do stuff for full bar before it's defined, or we can use it after including the definition. Yeah, this is what I'm doing. You want to declare, you can declare default arguments for a template only for the first declaration of the template. If you want to allow users to forward declare a class template, you should provide a forwarding header. If you want to forward declaration to someone else's class, you are out of luck. Wait, I don't understand. Can I not forward declare templates in C++? Can't remember now. Problem is that you can't declare template member variable. How could you specify the template argument for them? See, I thought this would be okay because we're declaring a class called audio file that takes a type name, a template, and then we're just saying that that template here is float. Never thought I'd be watching a forward declaration tutorial again. Yeah, I mean, this should be fine as far as I know. As far as I can tell, this should be okay. Audio file is in the unique pointer, and you can definitely use incomplete types with unique pointers, so I don't see what the issue is here while compiling it. See the first reference to default. Oh, is it because, yeah, because it doesn't know how to delete it, and that's the issue. So if we do wave file equals default or something. Good message to the first reference to default delete operator in unique file. I guess I just have to declare a destructor, right? That's fine though. It's a little bit annoying. I forgot about that, but and again, one of the things I definitely love about C++ is the how straight to the point the compiler is and telling you exactly what the error is, right? It's not really, I mean, I think it just means here that you have to basically define a destructor only after you know the type of the, or what class this audio file is. That's it. Oh. Oh yeah, so that is it. That's essentially it, because I don't need to define anything here, since the unique pointer will do the destruction itself, right? So hopefully that error disappeared now. Hopefully. There you go. Yeah, I mean, how would you tell if someone's been coding in C++ for years is when they know this little details that the compiler kind of doesn't tell you about, really, or it tells you in a very convoluted way. But that's fine. Okay, and now, yeah, let's actually run this shit and then see if we can get some data out here, right? So get data. We have a little program and we create that right access violation. I love these. Love these. What is I in this case? Number of frames equals to that. We are basically halfway there. Now, which bit is giving us the violation? That's the question. What is this times 2? So 8,874,992. 992. What is number of frames? Yeah, this is not matching, is it, guys? Because we have 8,874,992 here for this case, which is definitely more than the number of frames. Get number of samples per channel. So I don't understand. So the number of channels per should be the same as the number of frames. And each frame is basically however many combination, like set of samples we won in the end. So what is going on here? So the buffer should have enough space for the number of frames, and each frame has, as we know, I guess two channels. It should be here. I guess we can see, right? We can run it again and see. We can definitely run it again and see. So the number of frames is, as we said, this value here. Let's open a notepad and put all this information in. So number of frames is equals to that. And the format, samples, see we have 2 samples. And this will go for a while and a while and a while until it fails right here. And it fails when I is equals to this, right? So it fails when I is equals to this, which means that I times 2 is equals to 170, what was it? I actually forgot. When it's equals to this. Which is definitely more than the number of frames. Definitely more than the number of frames, yeah. I am starting to think that the number of frames in the Qt audio buffer isn't actually matching the, what it should be. It's doing the number of samples instead, like overall samples. It's a little bit of a shame. The individual samples will be initialized to the default, okay. The individual samples will be initialized to default, yeah. So let's do that, I guess, right? Let's, instead of creating this, let's create that times 2 and build it. Hopefully this time it should work. I'm really hoping that I don't get any DCMA strikes on these songs, because this is a new playlist. There we go. So the value, data. Oh, we have some data. And the pointer is this, right? So we can get the pointer here, right? Let's inspect the binary for this and see what the hell we have. So value, dude, come on. Value, data, and the pointer here. And the size is big. So the size is this, right? The size is equals to this, because each float has hopefully 4. What should it be? What should it be? My number of frames was this value. So it should be this overall. This is the size I'm expecting. What I'm getting is a little bit different, I guess. Very different indeed. So value, data, pointer is equals to that. Array data. I don't know if it's right or not, to be honest. I can't tell. However, let's try and play this and see what happens. Let's try and play this. Look at that step by step. by array, audio output start. So I can have an audio device, I guess, right? Let's close this. Audio output, include Q audio device. How do I set the format for this? Is default mode is default, is format supported, preferred format, supported sample formats. Like you can write the Q audio buffer data to an IO device. Audio output. Q audio output is what we need. Our Q audio device. Q audio output. Okay. What functions do we have here? I guess start. Q audio. Does this do anything? So Q audio output. Right. So what do we have here? Q audio output. We do have a start. This is Qt5 though, Qt6. Oh, so in Qt6 this changed. Nice. Good to know. So Q audio output Qt6. Yeah, it seems like they've removed the class or changed it a lot, I guess. Q audio device, there's no signals. Okay. Q audio sync. The Q audio sync provides an interface for sending audio data to an output device. Detailed description. You can construct an audio output with the system's default audio output device. It's also possible to create Q audio sync with specific Q audio device. When you create the audio output, you should also send in the Q audio format to be used in the playback. Cool, yeah. Starting to play an audio device is simply a matter of calling start with the Q IO device. So what's the Q audio format? We've got that there, Q audio device. Okay, cool. So we should just create an audio sync with the format, and that should work, right? That's what I'm wondering. Okay, so this returns something. So auto device device dot how do we send? Send. They put play. Come on, what is the thing here? Okay, so Qt audio sync is what I need. I know that. And then there is a start function. And QIO device. And then there should be a functioning in this one to kind of write to it, right? I guess. Is there a Q buffer anywhere? Read line, read, seek. Like, how do I just write things into this audio sync? That's what I'm looking for. There you go, right. That should be this one, right, I guess. Q by array data. So we should be able to do a write in here. Does this build? Device. Expression must have a class bars type IO device pointer. Sorry. Does this let me work with it? Key device no overloaded function could convert all the arguments. Audio file.get data. Ah, yes. Because it's not a value. No. Does this work? No overloaded function can convert all the arguments. Okay, that's fine. How do we convert this? To the bytes, I guess. Q audio buffer. And what does this take? The write function. So I want a Q audio buffer to Q. Which class is it that I want? Q by array. Read a sample by sampler is 2 bytes at a time. More like this. So you want to play Q audio buffer. With a Q audio Yeah, this guy's suggestion, I see how it doesn't work now. It's because this suggestion would work if the audio buffer was storing 8-bit sort of like samples, but in my case it's not. So what is this person doing here? So it's lot get music data, slot play background. So audio device, right, data.data, data.size, Q byte array. I guess we can try something similar, right? So instead of this one, we can use this one here, so the Q length instead. How do we get that? So we get the data. So we get the audio buffer, also const audio data. So we have the byte count there. Do we have the byte data as well? Explicit shared pointer data. Operators valid swap. Oh, this is private. How does const data not work? Is inaccessible. Ah. We've got the buffer. I just want the data. So audio. This will return me. Maybe it would help if we go to the documentation and look at the data function. So this is what we want here. So the returns a pointer to this buffer's data. You can only read this method is preferred over the const version of data to prevent unnecessary copying. There is no checking done on the format of the audio buffer. This is simply a convenience function. Okay. So they are both the same. So what I need to do is I need to get the start here, and I also have to get, what do I need here? I need const car, right? So const car is what I want. So const car star. This is what I kind of want. Const data. And I also want auto const the audio data size. And that will be audio buffer, the byte count. And then, only then, can we do the audio data here and the audio data size. Is this gonna work now? Does this complain? Let's do a build and see, I guess. What is this expecting, man? Okay, now it works. Now I know that this is not gonna work on the first time. It's gonna play some gibberish, but let me turn the volume right down and run this. So you get that. We do the audio data, create the audio sync, we start. and it just plays gibberish, as I said. I'm not sure if you guys can hear it, but let's do it again. You see that? That makes no sense, but it's fine. I mean, I kind of expected this. Now the issue is, I guess we have to find what the issue is. I would probably say it's on this get data function, to be honest. In fact, it's probably going to be this one here. So data, instead of QReal, I probably want something else. I definitely don't want QReal. It should really be a float there. Hopefully that works. That's one of the first things I kind of notice. Does this build? That's my question. Because it should really. Okay. Now let's see this. That was much better, you see. That actually made some noise, I guess. But what's the audio data size? So this is the audio data size apparently in bytes, right? So the byte count. So this divided by the size of floats is equal to this. And this divided by 2 per channel is equal to that, which is like twice what we actually need. Somehow we're doing it twice over. I don't know why. But this is much better. I'm much happier with this because you can see that it does start to play the anthem, and it makes some sense, right? So I'm gonna do it again so you can hear it. It starts playing it, it doesn't play the whole thing, and I don't really know why, to be honest with you. But I guess we'll figure out. We will definitely figure out. And it's probably because this device maybe stops or something, I don't know. Can we do an audio output or wait or something? What can I do here? What can I do here? So I guess Qt audio, Q audio sync, not playing whole buffer. I don't really know how or why. It kind of seems to me that the whole buffer isn't being set, if it makes sense. So but this is much better anyway. I'm going to keep playing the music here. And then let's debug this together now, because it'll be a long ride, I can tell. So I set the audio output device and the right, and it's star. And I write to it. think might be an error. I don't know. We can query state, I guess. What is the state that we can get? Active state, suspend the state, stop state, idle state. Suspend the state and turn. What if I just do something like, you know, just to be very lazy. So while song playing, we can query the status. We can do a device status audio. Something like this. We just wait for it, and then we break. And then the default, anything else that's not playing, we kind of set the song playing to false. And we don't need to break here because it goes over. Okay, what if I do this? What happens if I do this? Like ideally in the future, like all of this stuff with, you know, writing to the buffers that I'm doing in Qt and kind of reading the state, this would probably be done with the Qt slots and signals, because you can have like this sort of observer pattern thing in Qt where you have this sort of like callbacks. So whenever a state changes in the song playing, a function will be called, and then you can actually, you know, set your program state accordingly to that via some callback function. So this is ideally what we want to do in the future, but for now I just want to basically play the whole thing. So I just want to see if this fixes it, because my suspicion is that we start playing the audio here, we write to the audio buffer. However, when we start executing the program, I feel like Qt does something with the playback. I don't know, maybe. I don't know. I can't really say. But the only way to know that is basically to hang this until we can no longer have, once we no longer have an audio playing, right? So let's see this. If it doesn't work, it doesn't work, but oh well. Yeah, it didn't work. It didn't work. So right. Yeah, so in fact in here we're on a forever loop, because it doesn't even begin to play. It doesn't play past this point anyway. So what is the issue? So Q audio sync right only playing. Part of song or something. I don't know how to describe this problem. Yeah, this is just me reading the stuff. I'm making sure that I kind of have a mental model of how this works, basically, so I can understand what the issue is. Yeah, what if I didn't actually... I kind of feel like this buffer is definitely too big for it. So let me try and write just like part of the song at a time. So this will be like in a for loop or something. So while... I guess we can kind of do it here, really. We can repurpose this shit. Audio data... Yes, to this. So auto. Now, if we have, is it 44.1K and this? Oh, Jesus Christ! I didn't realize I had all of these open. There you go. If I have 44.1K per second, right? So 44 and 100 samples per second. If I divide it by 10, that's 100 milliseconds. If I divide it by 100, it's 10 milliseconds. So let's send it in 10 millisecond chunks, right? So the chunk size is going to be 441 here. And then the auto offset, it's just going to be 0. And then the offset it's going to be plus the chunk size. And then if I guess the offset plus chunk size is more than I guess the, let's say we just want to play it for like 2 seconds, right? So what is that? That times 2. That times 10 actually. If it's more than this, just for testing purposes, we're gonna set the song playing to false. Okay, so let's try that. And again, I'm gonna rebuild this. Audio. The following error is treated. Wait, what? The following local variable is not okay. I'm just going to comment it out for now because I do need it to rebuild it completely. So, you know, the logic of this code is that I'm just going to try and play it for 10 seconds. But I'm going to send very, very small chunks. So I'm going to send like 10 millisecond chunks. And this is essentially means that I'm sending 441. Actually, yeah. So chunk. This is in floats, right? So this is how many float samples we have if you want 10 milliseconds. But if I want the size in actual bytes, it's going to be the size of float times 441, right? So that's kind of what we want. Now it truly should play kind of 10 seconds. Otherwise it would have played it for like 2 seconds and a half. So if the breakpoint hits, No, it still fails. It still fails. It still only plays for a little bit, and then the rest is gone, which is a bit shit. And I can't tell exactly why. However, because I'm going to call this stream here, call it a night, what we did manage to do is to have some code that will essentially load the data of the song from a WAV file, and then play part of it, I guess, so the very start in Qt, right? And there's obviously something going wrong in Qt. I need to basically analyze and see how, like, what is going on, because there is something I'm setting up, like, not quite right here, that's maybe creating an error internally in the audio sync, and hence why the song is not playing anymore. But yeah, I guess we'll figure out. But yeah, for that, I'm going to leave it here for today, guys, and thank you if you're watching this in the future. There haven't been many people watching it live. I understand it's a Saturday, but it's, you know, it's been fun for me regardless. I'm learning a little bit of audio programming again, because I keep going back and forth with it. I do some of it for like a month in a year, and then I don't do it for 2 years, and then I get back to audio programming. So it's good to learn these basic things again. Aside from that, I will leave you here. So thank you and have a